All right, thanks everybody for coming today. I'm Jeremy. I'm not sure I've met everybody at the meetings. And also today we have Conrad and Adrian, who's going to help do some instructions. So Adrian's going to actually record all of the modules and he'll post them on irongeek.com next week, which will give you a way to go back and review if you would like. And Adrian's also going to do a cameo today on web shows. So, also want to make sure I mention Carl, who is helping get all the food today. So he's everyone's favorite guy today. And Nancy Wheeler got us the room. And Jan, I'm not sure if Jan's in here, helped us a bunch with the setup this morning. And then also, we'll make sure we mention Sullivan, who provided this room. This is Sullivan College of Technology and Design. And then the ISSA is paying for lunch today, so thanks ISSA. Let's see if we can kill the antivirus. The reason why we're here today is we're supporting a charity, Johnny Long in Africa. He builds classrooms and provides computer training for folks over there who wouldn't otherwise have that opportunity. And that can be a big deal because getting a job in the computer industry pays well in most all parts of the world, and Africa is no exception. And that can make a huge difference. People can actually earn enough money to support their entire family. So definitely a good cause. So while we're here anyway, we might as well kill some time and hack some websites. So we'll do that too. Carl, did you?
Right now we're at $1,130, but it looks like we have a few more guys.
Wow. All right, great. So, well, definitely appreciate everybody pitching in. That really added up, makes a huge difference. So today we're going to basically work through doing a couple introductions to the tools real quick, and then talk about how web browsers and websites work at a high level, and then we're going to jump right in to spidering, proxying, talk about context, prefixes, and suffixes that'll lay the foundation for the rest of the material for the entire day. After we get that out of the way, then we'll start in on the first module that has to do with actual pen testing. That's going to be SQL injection with Conrad. So the tools we're using are Mutillidae. It's a purposely vulnerable web application that implements about 42 vulnerabilities. It has all of the OWASP top 10. It has a good chunk of the SANS top 25 that applies to web. It also has some other vulnerabilities that are not going to make the top of any list, but they're commonly found by web scanners. So if you're using Mutillidae to test a web scanner, which is one of its purposes, it provides the opportunity for the web scanner to demonstrate what it's able to find. This project actually was started by Adrian, and the original version, version 1, is still available on SourceForge on the same exact page as version 2, this new version. And then this new version has been architected as an object-oriented version and designed to support instruction in classrooms and educational environments. So the other tool we're going to use is Burp Suite, and this is an interception proxy, meaning that it sits between the browser and the website. It's running on your machine, so as the traffic leaves the browser, but before it actually goes to the web server, you have an opportunity to observe the traffic and change it in any way you like, and that's going to be important today. I'm running all of this in a virtual machine because Mutillidae is very vulnerable. It's deliberately vulnerable. It's supposed to be vulnerable. Running it on a host is not a good idea. So now's a good time to mention that we brought in a wireless router, HackerNet, password the same as the SSID. It's not connected to the internet on purpose. It's not connected to the school. It's just sitting up here on the podium. It's for you to connect to if you want to be able to see each other's machines. Like if you have a lab partner and you want to attack each other's machines, then you can connect to this network. do not connect to the school's network, and simultaneously perform any kind of pen testing. Your traffic may accidentally get onto their network.
So, do we get to that point when we get off the guest network?
Mm-hmm. Yep, if you don't need to be on the internet right now, you can just go ahead and disconnect. That way you won't accidentally forget. All right, so next we're going to talk about just very quickly how the web works at a high level. So the browser itself is going to make a request for a file from a web server. We can actually observe that. So on Burp Suite, I'm going to turn on the proxy here. And let's say that we try to go to page user information. So we can see in the proxy that the browser is actually requesting a file. In this case, it's this file right here. And it index.php, and it's passing in a parameter to that file. We forward that on to the web server and wait. The web server returns the file back to us. What makes this site different than, say, a static content site is that the file is dynamically generated each time that you make a request. So PHP is looking at the request and then creating the HTML document on the fly based on the code that's in the PHP source code. So it generated this response, which is an HTML document that we requested. We can forward this back to the web browser and look at the page. It's important to keep in mind that what you see on the screen here is not the web page. I know it looks like a web page, acts like a web page, but this isn't the web page. This is Firefox's interpretation of what it thinks the web page should look like graphically. If we view the page source, so this is really the page. There could be a lot of different things that you're going to find on the actual source code that are not actually rendered by the browser. So when you're doing testing on sites, it's a good idea to get used to looking at the site this way and not necessarily how the browser interprets it or renders it. There's a lot of things that happen, especially nowadays in websites that are never rendered in the browser, because with the Web 2.0 or AJAX request, the request is going off in the background based on an event other than you requesting a page. And the response is coming back and being parsed in the background. It doesn't necessarily actually change anything on the page. It might visually change the page, but a lot of times it doesn't. So is there any questions so far about requests and responses? All right, so let's go on to spidering. So one of the problems we'll have right away when we first start assessing a site is how to get started. It's kind of that blank page syndrome. It's like, where do you begin? Well, generally the first thing you'll do is the reconnaissance phase. You'll find out as much information as you can about the website without actually going to the website. And so you're going to go out to Google, look on there to see what information you can find. You'll use a tool like ReconNG and use that to do the reconnaissance to pull in as much information as possible. And you can go out and figure out what kind of server is running, what languages are being used in the site, what the site looks like, and even visit at least a fairly recent version of the site without actually ever touching the website. So you can go out to the Internet Archive, Wayback Machine, and get what the site looked like at least somewhat recently. It's usually about once a month or so they take a snapshot, it seems like. You can go out to sites such as Domain Dossier and figure out the domain name registrar, some of the services that are running on the host. And all of these are passive reconnaissance. We're not going to cover a lot of the reconnaissance phase today, but definitely encourage you to take a look at ReconNG. It's got a lot of modules built into it that'll automate that process and then automate the parsing of the content for you. So make sure the intercept is turned off. So Burp Suite is broken up into these modules that appear as tabs inside the tool. The target tab is where you're going to find the information about the pages that you visited. There's going to be a sitemap. So for example, every time that we visit a new page, we're going to see that appear in the dark text that you see here. Now you also see a lot of other pages that are in this lighter kind of grayish text. Does anybody know why those are gray instead of being...
But you haven't gone there yet?
Yep, we haven't visited them yet. But Burp somehow knows about these pages that we've never even visited. So what's it doing in the background to be able to list these pages out?
Spider.
It's not spidering actually, it's doing it passively.
Just looking at the code and see what...
Yep, it's just looking at the code. It's looking for any kind of anchor tags, any hrefs, anything like that, then it can be pretty confident it's going to link out to another page. So it is possible it may actually link to, it may list something here that doesn't even actually exist because it is passive. When we click on a particular page in the sitemap, we can see the requests and the responses that have been made to that page over time. So if we, let's just refresh this page just to cause another hit. And if we go back to the sitemap, see, I think I need to actually do something. Okay. So now a new page appears in the list. And every time that you visit a page, you're going to see the request and the response. And you can go back and look at those. And you can save these out too, but I believe that's only available in the Pro version to save what you've actually done for the day. We'll be using the free version all day today. We're not going to use any of the functionality of the Pro version. So the next thing we would like to do after visiting the site is we want to get a list of all the pages that are in the site so we know what the scope of the test is going to be. The easiest way to do that is go over to the site you're interested in. I'm browsing localhost today, so I'm just going to click on localhost and hit spider this host. But if you're browsing out to an IP address or what have you, you'll see the domain listed here and you can right click and spider. Whenever it runs into a form, it's going to ask you for help in filling out the form because there might be a page behind that form that you can't get to without submitting the form. If you want to see how the spider's doing, you can go to the spider tab and it gives you some output that indicates how it's crawling right now. And if we go back over here, we should start to see some new pages appear in the list. And it looks like it's going through and finding some different forms and stuff. So we can let that run in the background. One of the things you want to do is, right here, if this line says add to scope, you want to add your projects to scope. So I've already added it, that's why it says remove. And that gives you the ability to go up here, click on this mysterious menu bar that doesn't really look like a menu bar, and show in-scope items only. This site might link out to 100 other sites that are in different domains. It's not uncommon for sites to link to Twitter and Facebook and what have you. this helps restrict that scope down. Otherwise, you're going to see a whole lot of other sites listed. And that can clutter up the display quite a bit. Okay, does anybody have any questions about spidering or the sitemap, or how to use it? Right, and then probably one of the most important tabs to get set up is the Proxy tab. This is going to allow us to intercept the traffic. By default, the intercept is on, but in the options, by default, intercepting responses is usually unchecked. The way I like to set this up for the intercept is to intercept if the URL is in the target scope that we talked about a minute ago. And also, I generally leave the condition that it doesn't match a picture or a cascading style sheet or something like that. I generally edit the file extension line and add JPEG in addition to JPEG. By default, it doesn't, a lot of versions don't include JPEG. And then I'll generally copy that down to the server responses. So intercept the response only if the URL is in the target scope and does not match the exact same condition that we had in the top. You can click edit on the top one in order to copy and paste this match condition out so you don't have to type it. The options contains a lot of other information here at the bottom where we can automatically modify the response as it comes back from the server. So for example, you can disable JavaScript validation automatically. This new one, you can remove the secure flag from cookies. I believe this came out a couple months ago. You can SSL strip the responses, so you can convert the HTTPS to HTTP, in other words. That's relatively new as well. And some other features. Down here in the match and replace, you can look for patterns inside of the responses and automatically change them to something else. So for example, you could change the user agent string to blank or some other user agent string that you want to change it to for testing purposes. Alright, so it looks like the spider's done because the request queued is 0. So if we go back over here to our target, we should have all the pages spidered. Notice that Burp will show the pages that it itself submitted as the dark text, the visited text. So you may not have actually gone there. It may have been the spider. The scanner tab is only available in the Pro version, and we have the intruder, the repeater. These two are similar in that they let us manipulate the requests using automation. So we can script a bunch of requests to automatically occur instead of having to visit the page, modify the request. We'll show these off and on today. The repeater tab is especially useful. The repeater tab lets you capture a request and then submit it to make sure it works. And then you can come up and change any of the values and submit it again and see the response appear below. You don't have to go back to your browser and keep using the browser and intercepting those requests. It's a lot more efficient. And you can render the site in the response down below to get an idea of what it looks like. It will not execute any JavaScript. This render tab, it just gives you a visual. That's a basic overview of Burp Suite. Right, so we have spidering and scoping and proxying. So next we'll take a look at identifying injection points, canaries, prefixes, suffixes, and some encodings. Okay, we'll stick with the page user info at first. first here. Let's see, let's turn the intercept off for a second. All right, so we have a web page and we've been assigned to test this page. What do we do next? If the page is completely static, there's not going to be much you can do with the application as far as testing it for vulnerabilities, because if you don't have any ability to interact with the application, if it's a purely static page, there's really no way to pass in any input to change how the page runs. And you can certainly still look for vulnerabilities in the actual server itself, for example, Apache or IIS or what have you. And there could be vulnerabilities even in static pages in some cases. Tools like Nikto are pretty good at finding vulnerabilities that are already well known about a particular product. Generally, it's going to have more trouble with dynamic applications that are unique. But that's one option for testing static sites in a fairly automated way. So to find the injection points in this page, I'm just going to make a request, it doesn't matter what it is, and then capture it in the intercept of Burp Suite. So we'll submit the form, and here we can see the request. There's three basic places I'm going to look right away. I'm going to look at the URL to see if there's any query parameters that are passed. Could be a get or a post. The gets will typically have the URL query parameters most of the time. If it's a post, we're going to look for those same parameters down here in the body. Burp can convert these gets to post or vice versa. So we could say change request method and take a look at what this request would look like as a post. You can see that the parameters have moved down into the body. We're also going to take a look at if it's possible to send an input via any of these request headers. So one of them that jumps out right away is being able to pass input in is the cookie. That request header has name value pairs, and we can change the values and submit those to see what happens to the site. So we basically have three different places. We have the body, the get, and then the request headers. If you click on the params tab in Burp Suite, it'll make a list of those the obvious inputs for you. So it's going to show you the cookies in the body in this case because we changed it to a post. But if we change it back to a get, it'll show the URL query parameters. Is there any questions about using Burp Suite, locating injection points, or even just capturing a request? Is everybody able to capture a request okay?
Can you change a get to a post again?
Oh, sure. So it's change request method.
Oh, okay.
Just right click anywhere, it doesn't really matter. Usually I just go for a blank spot in the page, and then that'll give you the list of options.
If you have a post and you think there's cross-site scripting or something, you could just change it to a get through that?
Yes, but there would have to be a secondary vulnerability in the application, and there often is. So it's what we call a second order vulnerability. It's not a direct problem in and of itself, but the ability to switch back and forth between gets and posts is called method tampering. It's not something we're going to cover today, but it's generally used to try to bypass filters. Also, it can be useful in making things like cross-site request forwarder easier. So, for example, let's say that the page expects to get a post, and the developer thinks that's how it's going to come in because when they set up the form, they set the method equal to post. But they might make a mistake. So, for example, in Java, there is the request. It's kind of like a super global variable, and it exists in PHP as well. And what the request does is it'll take the parameters in from either location. It doesn't actually care. And in PHP, there's a preference to the order that it'll parse. You know, it would rather have the variables from the, I think it's the get first and then the post. So like if it sees the variables in both locations, it'll pick one or the other. And I can't quite remember the order. I have to look it up. but you get the idea. And so if a page were vulnerable to cross-site request forgery and it's also vulnerable to method tampering, it would be easier to exploit that page with a URL than it would be trying to, submit the post. You can still submit the post. It's not, fixing method tampering is not going to save you from any vulnerability. It just makes it a little harder, slightly harder.
Excuse me.
Yes.
I'm not able to answer that.
Are
See.
you using the Samurai?
No, just using Command P.
Do you have set to use localhost port 8080 as your proxy in your web browser?
Yes.
You go ahead and continue. I'll
Okay.
see if I can think
Thanks.
of it.
Appreciate that. Okay. So we found some places that we can put some parameters. And we'll go ahead and forward this on. Maybe we change something. And we'll forward that on, wait for the response, and then we can look at the response in the web browser. All right, so that basically covers injection point identification. Next, let's take a look at canaries. One of the issues that you have in an engagement is you're trying to test a lot of pages, and the pages themselves can have a lot of variables. It can take a lot of time to try to figure out, when you sent in an injection, how did it affect the response? What effect did it have? So one of the ways that we deal with that is using canaries. A canary can be anything that's relatively easy to find. I recommend it be alphanumeric. The reason being that whenever a web page encodes output, alphanumerics are not encoded. So if your canary contained an exclamation point and the web page changed that to whatever an exclamation point is, and pound 26 semicolon, then you're not going to find your canary when you search the response. So if you do greps or whatever, it's not going to appear because the exclamation point got altered. But typically speaking, alphanumerics are not altered in most encoding libraries. It's not always true. Probably nothing we say today is always true 100% of the time, but that's generally the case. So the canary that I want to use is canary. And we'll see where this name field here ends up in the response. Turn the intercept on, view account details. Okay, we can see the input parameter here. We'll forward that. Just because we send in an input parameter doesn't mean it'll show up in the response at all. So you can have a null case when you go to your search.
Are we supposed to be following along with you on the page here? Because I'm afraid,
You can if you like.
well, yeah, I think we'll need a timeout later because
Okay,
I'm not sure.
you can follow along. But right now we're really just kind of covering some basics.
Showing the concepts, right?
Yeah, right now we're trying to do concepts. Feel free to follow along. In the next module, Conrad's going to have an exercise, so you'll want to kind of have just the basics of how to do this down, and then he'll give you an assignment. He's going to give you an injection to submit, I think. Is that right? Okay. So, okay. Down here at the bottom in the search bar, might be hard to see if you're way in the back. I'm going to type in canary because that's obviously the canary I had. All right, it's showing up in this on click. And it looks like that might be about it. One match. Okay. And for the second field, we don't want to use the word canary because obviously we wouldn't know if it was the name field or the password field, so we need a different canary. So we can do, say, canary 2, or probably a better one would be like canary password to relate it back to the name of the field. Okay, so I'm just using can user and can pass. Forward that on. No matches. And it looks like that no hits at all. So when the username and the password are not correct on this particular page, it turns out that it doesn't reflect those values back. All right, let's take a look at context. So we'll stay on this page for a second and talk about SQL context. When we're fuzzing a site, basically throwing all the different characters we can think of at each of the parameters that we found, plus throwing special characters or special character sequences at all those fields. For example, we might throw a list of partial or complete SQL commands at a field to see if it has any effect on the backend database. We may send in some special characters that are useful in building JavaScripts to see if they get encoded or not. But in those cases, what we're doing is we're fuzzing looking for some kind of reaction. So let's say that we fuzz this field with a single tick and a double dash and a slash slash and a double quote. So if I'm fuzzing with those values, what context am I probably fuzzing here? Best guess. Could be a few different ones, but
Error messages?
error messages from what server? From the database server. It doesn't have to be SQL Server, but definitely looking for probably a reaction from the database. Those are all special characters in databases. Might throw in / star as well. Okay, and sure enough, that sequence of characters caused a reaction, and we got back an error message. So we have another vulnerability already. We have a application exception disclosure, or some tools would call this, would actually report this as multiple vulnerabilities, because we have a platform path disclosure right here. It's giving away the internal system path of the web server. The entire box here is an application disclosure. We have a application path disclosure in multiple places, and then we also have an SQL message disclosure. So the error messages in Mutillidae are really fun, and they're that way on purpose to make it a little bit easier. We can find our injection. It's right here up to the star, so actually it's right here, I should say. And that leads us into our discussion about context. Whenever we send in an injection and we're trying to get some kind of reaction back, we need to plan ahead to think about what context it is that we're trying to inject into. In this case, if we're looking at SQL, we need to be mindful that it's going to land in the middle of a query or an SQL command of some type. Oops, sorry, I hit the reset the database button. So fortunately, we can just repoison ourselves because we sent the same canary right back in. So the items, this injection landed right in the middle of an SQL statement. So you're not going to be able to just finish the SQL statement, because there's going to be a portion of the SQL statement that's going to be left over at the end, and there's going to be a portion of the statement that comes before the injection. So you have to deal with that. We figured out what context we're in, so now we can talk about prefixes and suffixes. So if we look at let's send in something a little simpler, so we'll just send in canary and a single quote. so we can see the error message a little bit easier. Okay. So the canary single quote is our injection. So we can already tell by looking at this that we're probably going to need to prefix our injection with any arbitrary string we want, because we can set the value of username with this injection, obviously. But at some point, we're going to need a prefix of a single tick, because we're going to have to close out the one that's already being supplied by the application code itself. If we don't close this one out here, our injections are not going to be syntactically correct. They're not going to form a syntactically correct SQL statement, and they're not going to work. We're also going to need some kind of a suffix too, because this single tick is supplied by the application along with the end of the query, and the password is equal to whatever password we pass in. So we're going to have to deal with that as well. We either need to make the SQL complete, or we need to at least figure out a way to get rid of the end of here, this ending here. So we're not going to go into SQL injection right now, but just to talk about the context and the prefix and the suffix, we can go ahead and use, say, the prefix of single tick, and then we'll just use a suffix of -- space. This is a MySQL server, so a -- space is a comment. And then we can add a payload in the middle. So we use the canonical 1 = 1. Let's turn the interception back on. Oh, actually, we're not going to see it anyway. Okay. So I'm going to cause this to have an error on purpose so we can get the error message back. So I'm just going to add an extra tick. So the first tick that we added closed out the username field, and then the comment we added comments out the entire end of the SQL statement. And then what's left in the middle is whatever we want to have happen. So in this case, we're just trying to form a tautology to make the statement true. You'd be trying to bring back all the results for the entire table. Is there any questions about prefixing or suffixing or context?
Is the space after the -- necessary?
Only in a MySQL server. If it was an SQL server, it would not be. Or Oracle either, actually. We are using a MySQL server here, so we would need to include that. Okay, we'll take a look at some other contexts. So we've covered the SQL context. We'll go to the document viewer for the HTML attribute. Menus are getting a little big, it's hard to find stuff. Let's see. There we go. Looks like it's under cross-site scripting via HTML. Excuse me, it says HTTP attribute, should say HTML attribute, so that's a bug. Have to fix that later. All right, we're going to turn the interception back on. Submit whatever, it doesn't matter. Here's the path to the document. Put in canary and see what happens. So I believe this field is vulnerable if we were to go ahead and fuzz it. Okay, good. So we can see two matches. There's two contexts here. There's an HTML context. You see the first canary, or the first instance of it, landed between div tags, or within a div tag. It's the text element of a div tag. and it's mixed in amongst some other text. And it looks like it's just surrounded by double quotes, which is really just text in the HTML context. We also have another interesting context that we've landed in the source attribute of an iframe. Okay, so given that context and assuming the appropriate prefixes and suffixes, what would be a good vulnerability test for this iframe context?
Reflected cross-site scripting?
Yep, that's a good one.
CSRF.
CSRF, let's see.
The frame source and put it to a.
So that would be like frame source injection, which
Yeah, frame source
could lead to CSRF.
If you can put a JavaScript.
Yeah, that's true. So the primary vulnerability or the primary attack, the first order attack would be frame source injection, and then you could certainly follow that up with a second order of just about anything, including
Social engineering.
cross-site request forgery. Mhm. Yeah, this could even take the place of social engineering, because if you can force the user to go to a third-party site, you don't even have to trick them.
True.
So you may have to trick them on clicking the link that gets this injection to work. So you may still need social engineering. If you want to try out some social engineering using an automated tool, check out Dave Kennedy's social engineering toolkit. And the tool we mentioned earlier, Recon NG, is by Tim Tomes. All right, so in this context, what would at least one of the prefixes probably have to be if we were going to break out of this context and do cross-site scripting? So if we're doing frame source injection, the prefix and suffix is basically blank, right? Because we just got lucky enough to land right in the middle of those double quotes. That's a pretty good day right there. But if you're going to do cross-site scripting, you're going to have to break out of this frame tag. You can't really inject JavaScript directly into the source attribute. And, well, actually, there's probably some browsers that would execute JavaScript, so that's probably not even true. But let's just assume for a second that no browser would execute that. So I'll give you a hint, work backwards. And then, after you get the prefix done, work forwards. So what's the very first character we got to start with if we're going to break out of that context?
Quote.
Yep, double quote. It's might be hard to see, but it is a double quote. Then what?
Space.
Don't need a space. I heard it over here though.
Close the tag.
Close the tag. Close the iframe tag off. Whoops, excuse me. I'm trying to make you seasick there. And then on the suffix, work to your right after the word canary, because that was our injection. That's our word. What would be the first character you would need for the suffix?
Start a frame.
Start a frame. Yep. And it doesn't even have to be a frame, but it could be. It could just be span or div or whatever, but you're correct. And then what's the next character that at least we're going to need? The next mandatory character, I should say.
So you started a tag, so we need some kind of source or whatever you want to put in there.
Not necessarily. You would need at least a space. At least a space, but I like where you're going because it'd be better to kind of make them more syntactically correct. So you're sitting at the Y in canary, you've just started a new tag, let's just say it's a div, just for argument purposes. Then we put a space after the div, then what? You still got a character hanging out there that the application is including in the source code. Here, let's look at it a different way. Send this back. So far we've closed off the frame tag that we landed inside of, right? And that was, we closed off the double quote. and then we closed off the frame tag, and then we're going to put canary back. We've opened a new tag in just span or whatever, it doesn't matter. Space. Okay, so let's submit that much and see where we're at. Okay, so we've closed off the iframe. We've got the word canary hanging there. That's going to be our payload layer. It's a placeholder. And then we've got that much done. So there's something wrong with that syntax. It's not right. We're missing something. Somebody from this side of the room. Just take a guess. Like that span tag doesn't look right, does it? Look at the iframe tag. It's iframe space source equals quote quote close frame. That's I mean, it doesn't make any sense, but it's a well-formed tag. It's still syntactically correct, even if it doesn't make any logical sense. The span tag is messed up. It's like span quote. That's not going to work.
Equal sign?
Could use an equal sign. We'd probably need a variable in that case. We'd have to say like span space, say A equals, and then what? Not colon. So it's the double quote, right? Because the application is supplying that double quote after the span, and we have to open that double quote up. We have to pair it up with a buddy, right? To make it come out. So we'll forward that. Let's try one more time. This is the hard part of getting the injections right. If you can get the prefixes and the suffixes and the context down, the rest will come pretty easy. Because the rest of it's just writing source code. It's just writing normal everyday JavaScript or normal everyday SQL. It's not, it's what any developer would do at that point. But making it syntactically correct requires the prefixes and the suffixes so you can break out of the context or stay in the context if you want to. Usually in SQL you're going to stay in the context. You're not going to break out because there's only one server that supports breaking out of the context, and the other, and Oracle and MySQL don't. But the SQL server you can break out, but typically you're going to stay in context. So, okay, so we had we'll talk about this here in a second. This URL encode as you type. So just ignore this for now. Canary, span, let's say A equals double quote. Okay, so there we go. There's a syntactically correct iframe tag. There's the placeholder for our payload, or what we can put in as JavaScript. And then here is a span tag that doesn't make any sense at all, but it is valid, right? So that's all we need. We don't need it to make any sense. We just need it to be correct so that the browser can parse and render the page. And the browser will be more than happy to execute our payload as long as the rest of the syntax doesn't cause any errors.
So the reason you wouldn't turn that into a comment is because you have no control with the end?
Right. Yeah, if we comment it out, in this particular case,
It's probably comment out the rest of
we don't have a way to get an ending comment character like somewhere later. Unless it just happens to be one of those pages where you control two variables at the same time and the two variables positionally happen to work out for you.
Right.
So I don't want to discourage you from trying that, but it just won't work in this exact page.
It'd probably comment out the rest of the page.
It would comment out the rest of the page, which would probably be a train wreck. So because you'd have to unclose comment. Now most browsers are super, super friendly, and they will do their very best to still make sure that your hack works. But you can't count on it, and if you're in a situation where you get like one or two chances to pull this off, you want to do your research up front and give yourself the very best opportunity to win. And in this case, I think this gives us a slightly better chance to win because it doesn't affect the footprint of the page that we're affecting is pretty small. I mean, we're really only messing with just a little tiny bit here. We're only really changing one tag, and we're changing it into two tags, and then with a payload in the middle. Okay? So at this point, we have a placeholder for our payload, and we need to cover URL encoding here in the next couple of minutes. So we've got about 6 minutes left in this module. So let's go ahead and skip ahead. Okay, I'm going to redo this. So one of the things I'm doing is I'm right-clicking on a blank space and I'm saying URL encode as you type. The reason I'm doing this is because some of the characters used in HTML, JavaScript, SQL happen to overlap with special characters that in HTTP itself, the actual protocol carrying the message. So if we happen to run across one of those characters in common and we don't encode it when we send it to the web server is trying to parse the HTTP, right? And it's going to see that character that's special to it, and it's going to get confused. It's not going to understand. How do I parse this request? You're liable to end up getting back a 500 server error bad request if you don't encode your input to match what the web server expects. So when we set it up as encode as you type, Burp Suite automatically encodes those special characters for us. So we'll do canary, span. You see it puts a plus symbol for the space. It puts a %3D for the equal sign. And then it leaves the double quote alone. And that's why we want a URL encode as we type. Did anybody notice, like in the second go around, I had typed span space double quote, but when it rendered it in the browser, it was span double quote. It's because the web server had stripped out that space because I had not encoded it as a plus sign. So this encoding here is called URL encoding. And over in the decoder tab, we can flip encodings. So we can say decode as plain, for example. Well, let's see, decode as, maybe text is what I'm looking for. Nope, maybe not. Let me try to convert it back to a regular space. A equals quote. Let's do encode as URL. Okay, there we go. Now the decoder tab encodes, when it encodes URL, it encodes every single character, not just the ones that are special to the web server. But if we take this back over here to the Proxy tab and replace this text here with that encoded version, fully encoded version, it should still work. Okay. So what happened was when that URL encoding got to the web server decoded it and then sent it over to PHP and let PHP do its thing, creating the file. By the time PHP saw the request, it was already decoded back into the regular text. All right, now we have room for our payload, and we'll talk about the payload later in the cross-site scripting module. Okay, there's a few other contexts. There's the JavaScript string context where we land in the middle of JavaScript as a string. So for example, you can have PHP write JavaScript, and perhaps you might take in the username or other field from the user and then drop that username into as a JavaScript string, var a equals whatever the username is, and when PHP renders that JavaScript, it'll hard code that value into the JavaScript string. So we might land in the middle of JavaScript. That is a happy day, I tell you, because the ASP.NET request validation is pretty hard to beat, but if you can find an injection that lands in the middle of a JavaScript, then you can generally get around the filter, because what you'll be passing in as the attack will not be HTML, right? It'll be JavaScript. because you're in JavaScript context. And so those characters tend to look pretty normal. They don't really look like an attack. They don't look like a tag, certainly. And it's hard to detect them. They just look like normal business logic. So a lot of times you can get around the ASP.NET request validation if you can find this context.
Jeremy, where have you seen those inputs? Have you seen that before? Where
Yes.
have they been?
In one product I tested, it was like a shrink wrap product I looked at. I'm pretty sure that it was a variable that was keeping track of kind of like where the user was or what they were doing or something like that. It wasn't an obvious user interaction input, but it was still a variable that was being passed from page to page. And whether or not the user is supposed to use the input is irrelevant, right? We control all the inputs, so we would fuzz them all and got lucky on that one. So, and that one turned out to be good because it turned out to be good that we found that vulnerability because the vendor was hesitant to do any security controls because they have the ASP.NET request validation, which is it's a good control. If you have it, turn it on. It's pretty solid, but like any filter, in the right circumstances, it can be bypassed. And in that case, we bypassed the filter, exploited the site, and we're able to get a patch. Filters are a defense in death, but they're certainly no substitute for code that's free of vulnerabilities. And then a context that's very popular nowadays that you'll probably want to get used to if you're working in this field is the JSON string context. It's getting very common that your injections will land somewhere in a JSON response, and you'll need to break out of that JSON response. Okay. All right, so since we're running a little behind, I'm going to leave those last two contexts for you to try. The password generator page has the JavaScript string context ready for you, and PenTest lookup tools Ajax version has the JSON context, and we'll be happy to give away these notes as well. And so why don't we take a 5-minute break? It's 10:01 on the clock here, so about let's say 10:07. We're going to start the next module, which is SQL injection.